Welcome everybody. We are today going to talk about APIs or application programming interfaces, which is one of the most important tools that you can learn to use in computational social science. So let's start out with what is an API? API stands for Application Programming Interface, and APIs are sort of a key conduit for information all over the internet and apps. So you could imagine an API for really virtually anything we do online now. Today, we're going to work through two use cases. One is to use the Blue Sky API, the social media platform Blue Sky, to try to collect some data. And so we can scrape, for example, messages from a social media platform. But then the second thing we'll do today is use OpenAI's API to try to automate some prompts. And there's a variety of reasons we might want to automate prompts. In our class, when we're doing research, usually we're automating prompts because we want to collect some data or test something about an API, or a large language model. But you can imagine that if you learn the skill of programmatically interacting with an API, you could do all sorts of stuff with LLMs. You could integrate them into other workflows. You could create multiple agents, and virtually everyone working with large language models right now, especially the big ones from places like OpenAI, Google, Anthropic, are using APIs. So APIs originally were sort of a way for a software developer or a researcher in our case, but we sort of have to think of ourselves as software developers today because most of the people who use APIs are software developers. So there'll be some like new lingo that might not be super familiar, like, credentials and authentication and rate limiting and things like that, that aren't usually part of most social science courses, but would be very familiar to anyone who's doing software development. And then we'll also have to realize that APIs, though they began as a way just to collect data and for one person to make custom data requests according to their 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 right to do so. So one of the things that's tricky is privacy is really important with data sharing. And so APIs are a way to ensure that only the right type of people get the right type of data. That was sort of their original purpose. If you can imagine, like, I don't know, like, let's say Instagram wants to allow people to share music better on their platform, right? And so they decide, oh, well, we better have a way to integrate Spotify. And so if you want to like share a Spotify playlist and on Instagram, you would probably, as a developer, you would like build an app or a plugin or something that would allow Instagram's API to talk to Spotify's API and send that information back and forth, or create an app that allowed a user to do that. So those are examples of data access, but the really cool thing that APIs can do now too is data analysis. And so, there are APIs for data visualization, there are APIs for AI, there are APIs for machine learning, all sorts of different stuff. So I chose the two examples today, Blue Sky and OpenAI, to try to give you an idea of the range of different APIs out there. First, I want to show you how many APIs there are. So APIs started off, maybe 20 years ago as a relatively fringe technology. Only the largest companies on the internet were building APIs, companies like Google, or sorry, internet companies, I should say. And even by 2018, there were, more than 20,000 APIs. And I don't have the current figure, but I wouldn't be surprised if it's 3 or 4 times that, because there are now not only many more companies that want to integrate their data with other data on the web, but there are even APIs that make APIs. So, and now large language models that can help people make APIs. So these things are just sort of spreading really, really rapidly. Okay, so hopefully you have a sense of what an API is now. It's going to get clearer, I hope, as we get into some examples. But broadly, hopefully you understand that APIs, or application programming interfaces, are tools that a computational social scientist, a software developer, or really anyone with a knowledge set can use to collect data, to analyze data, to process data, to automate different processes on the web. So what does an API actually do? Like, what does it look like in practice? Here we're looking at an example of a URL that I wrote to and get some information from one of Google's APIs. So you might be surprised to see that essentially what we're doing is generating URLs, and then the URLs produce data, and then we scrape that data. That's basically what we're doing when we work with an API. And so one of the tricky things of working with APIs is they're all different. So there's no like one set of instructions that I think, or anybody else can teach you that would tell you, oh, now you know how to work with APIs, because Google's APIs are different than OpenAI's APIs, which are different than Blue Sky's API. And basically, though, they mostly have similar characteristics. So most APIs have what you might call a base URL. So this here is a part of the Google APIs domain. And Google, by the way, has hundreds of APIs. So here we're using one of their map tools, but they have APIs for search and for news and for everything that Google does. Also now, of course, for Gemini, it's large language models. And so this is just telling, we're just telling Google in this case, which one of its APIs we want to use. We want to use its Maps API. And then the Maps API is a family of different things we can do. We could use it to collect data about world maps. We could use it to search for information within a given geographic region. But here we're using one part of the Maps API that's called geocode. And that's a tool that simply reads in text, unstructured text, so we could give it any kind of language. And then it tries to return geographic information like latitude, longitude. So if you can imagine that you're doing some research and you are plotting, let's say, protest events that you were tracking, or you know, you're interested in whether protests are spreading on a given topic across, let's say, college campuses or something like that. And so let's say you collected a bunch of data from Blue Sky, for example, and you said, we're going to use techniques to search for terms associated with protest, or maybe we're going to use a large language model to try to identify posts about protest. But then we're going to also try to extract from those messages the names of the universities where those are happening. And then we want to create a map that shows, let's say, all over the place where these protests are actually happening. To do that, we would need the latitude and longitude of, let's say, the center of each campus, and then we would maybe plot that on a map. So that's an example of why a computational social scientist might like to use this code. But you can imagine many other examples and many other types of Google APIs that might be useful. So we're sort of saying within the API, which part of the API do we want to use? And this is an example of using an API as a tool more than as a data source. And again, they can do both. It's a little confusing. But next, we've asked for a certain type of data format. This one is called JSON. We haven't dealt with JSON a lot in the class yet. It's essentially a very efficient way of storing data on the internet or in a digital source. It's efficient because unlike a data frame, which requires a list of rows and columns, each of which must be populated with a number or at least a missing data element, JSON, I'm going to show you what it looks like in just a minute, has the ability to have different types of data structures with different lengths. So we don't need to fill in those cells of a data frame with information if that information doesn't exist. And it just leads to a more efficient way to share data. It's frustrating though if you don't have a background in software development, because it is a unusual, for at least for social scientists, type of data format to work with. Fortunately, as we'll see, in many cases, other people will have written tools to help us process JSON data. But I just want you to get a broad understanding before we get any deeper into the content today of what an API is doing. Okay, so last, there's the query. That's the thing we want to send to the API. So in this case, we're asking the Google Maps API to use the geocoding tool within the API. We're asking for this data format called JSON. and we're saying we want to know information about Duke. So if we put this into the browser, and by the way, I think Google's API has changed, and this is one of the frustrating things about APIs, is that often little changes will be made in the name of something, and then all of your code breaks. So a recent example is, I don't know if you've been following like the naming of large language models, but it's getting like totally out of control, right? You've got like O1 mini, O2 this, O4, like it's just like, what are they even doing? The reason why they tend to follow these odd naming conventions or keep creating new names is every time you make a new thing, you have to change everything else that you wrote before. So that's why the people tend to default to giving things new names, I think, especially in APIs. You'd think we could solve that problem in this day and age, but it creates a surprising headache for the people who actually write this code. Okay, so in principle, you could put some URL that looks very similar to this into a web browser, and you would get something like this. This is the JSON data that we requested. So this is the output of our first API call. You can't really read this easily from the back of the room, but if you were up close, you could see that there's a bunch of information that the API provided about Duke. Probably most important down here, we have the latitude and the longitude. So in the example that I was just describing where we want to make a map, we would want to extract these two data points from this JSON. You'll see that it also gave us a bunch of other information, like that Duke is in North Carolina, or that it's in the United States, and the postal code, and which county it's in, and all this kinds of stuff. And that's typical that an API would provide lots of different information. And if we were making more sophisticated calls, we could ask for specific parts of specific information within an API. But often we just want to get all the data and then scrape it, which means like pull it down into our, let's say, RStudio or Jupyter Notebook if you're using Python. And then we want to do something called parsing it. And that means pulling out the little parts that we might want, like this latitude, longitude. Now, for the most part, we are not going to write in this class today sort of like full code to go from zero to the finish line, or the beginning to the finish line, with a worked example of an API. We could do that, but as I mentioned earlier, each API is different. So if we went through and carefully learned how to do this with Google, that knowledge wouldn't immediately transfer to OpenAI, because OpenAI has different names for things, different data formats, and different processes for getting to the data, which we're going to learn about. So I only wanted to show you what's happening sort of underneath the hood of the software we're about to use, in case you find yourselves further down the line, like maybe you've used a few APIs or you're getting more comfortable, and let's say you discover like there's a new data source out there that seems really intriguing to you for one of your classes, and you want to collect that data, or let's say you're writing a senior thesis or something like that, then you might find yourself writing your own custom code to construct URLs to make data requests or analysis requests from an API, return the data in JSON format or other formats, by the way. Sometimes we use formats like XML, for example, and then you'd write additional code to scrape and parse that code. And so you can see how doing this would require a lot of extra coding that we're not going to do today. If you want, like, one good tip when you are encountering a new API is to look at the developer documentation. So again, today we have to think of ourselves as software developers and not computational social scientists, only because the majority of the people who use these things are software developers. So most APIs have something called the documentation, or an API guide. And I'm going to be honest, they're pretty intimidating if you've never come to coding before, just because there's so much diversity in terms of how things are described, and there's such a range in terms of how well things are described. So some APIs, for example, the OpenAI API, is pretty well documented. We're going to look at the pages you would use to go through and learn how to use it in a few minutes here. On the other hand, Blue Sky's API is much less well documented. And probably that's because if you think about it, many, many more people are probably using OpenAI's APIs than Blue Sky's APIs. Also, Blue Sky is a very small company with very limited resources, and OpenAI is raising or trying to raise trillions of dollars, right? And so if you think about it, it sort of makes sense that large companies like OpenAI or Google would go to great lengths to document and even give examples, or some APIs even have what are called sandboxes, which are places that you can test out code or learn how to write sample code. But you'll just find a real variety of different documentation. And so one of the great frustrations of working with an API can be if you're working with an API that's not well documented, you may find yourself sifting through places like GitHub or Stack Overflow, sites on the internet that software developers often use to share code with each other in order to try to build code that works. So with all that said, let's dive into an example. And that example is the social media platform Blue Sky. I didn't pick Blue Sky because I think Blue Sky is any better than another social media platform. I picked it because it has an open protocol. What that means is anyone who has a Blue Sky account can collect data from any other Blue Sky user. So a lot of people actually don't know this. A lot of people think that their data is somehow protected, or unless someone follows me, I could get their data. But actually, and that's how many APIs work. So if we were on like Instagram, for example, you could only collect data about the people who follow you or you follow. And that's because, again, these companies have a huge obligation to protect user privacy, right? If the way the platform works is like let's say someone has a private Insta account, you don't want that data to be scrapable by someone who can use an API, right? And so we're going to learn about processes that companies and APIs use to protect privacy in just a minute. But we're starting with this open protocol, which means anybody can write code to interface with Blue Sky's API, just because it's a little easier to work with an API that's open rather than one that has these sort of privacy issues. I do want to point out, though, this does mean that anyone could scrape Blue Sky posts and use them for example, training a machine learning model or a large language model or whatever. So I will say for computational social science, there's probably some interesting research that can be done with Blue Sky, and it's so new that we don't have sort of marquee examples yet, but there are people using it to study politics, using it to study communication, using it to study marketing, all sorts of stuff. And if you've never used Blue Sky, and I wouldn't be surprised if there's at least a few of you who haven't, because it still only has 30 million users, it basically looks a lot like Twitter or Threads or the other sort of text-based social media platforms out there. So we have a user can follow people. The user produces a news feed. You see the feed of other people. Very similar to Twitter. There's some other nice things about having what's called an open protocol. So for example, I can change my experience on Blue Sky in ways that I can't in other platforms, and I can create custom feeds that allow the user to have a little more control over what they and others might see. And that's one of the cool things about having an open protocol. The downside, again, arguably, is that all the data is out there, and some people might not want all their data out there. So we're just going to write some very simple code to try to read in some of the post data from Blue Sky. So if you were to go and write the code from scratch, you would probably want to start right here, which is Blue Sky's developer API. And so here you can see we could learn how to build a bot. We could learn how to build an algorithm to drive users' feeds. So let's say we wanted to try to build, a lot of people are trying to build like feeds that depolarize people, that maybe expose people to a broader range of content or certain types of content, or there's like positive content, things like that. Or we could build an app. So let's pause for a minute to think of just like how many people might use an API for different reasons, right? Like the New York Times might want to build an app for Blue Sky that allows people to, from the New York Times, press a Blue Sky button and share something, right? And that's technically an app. Another funny thing about working with APIs, and again, this requires us to stretch our minds a little bit because many of you don't think of yourselves as software developers. Often we have to build an app in order to collect data or do an analysis. That's because most of the people using APIs are building apps. And sometimes in order to get the information we need to use an API, we have to create an app. Just sort of a strange conceptual thing that I think a lot of computational social scientists have trouble with understanding. They're sort of like, I'm not building an app, so why do I have to do this? Okay, so as you see here on this website, there's something called the docs up here. And that is where we would get a description of all the different endpoints and other parts of the API that we can work with. An endpoint is sort of like, you could think of it as a kind of data or thing you can get from the API. So for example, we're about to use an endpoint for posts. And what that means is we make a query, remember that long URL? Well, we're gonna use an R package that builds that query for us. And then at the end, the query is gonna be the name of a user. And then we're gonna request the posts endpoint, which will mean pulling down the user's posts. So, but we could do all sorts of other stuff with the API. For example, we could pull down entire feeds, or we could try to, figure out who follows who if we were doing a social network analysis. And each of those would require using different endpoints. You'll also notice there's a blog here because APIs are constantly being updated. So an example might be like if, let's say, Blue Sky is trying to facilitate data sharing with another platform that's using the open protocol like Mastodon or Threads, which are two other text-based platforms. Well, if there's one global change made to the way that to the tools, the open source software that all these platforms use, then Blue Sky has to update its API possibly as well. And so, like so much of open source software that we've learned about in the class, APIs are sort of ever evolving. And one of the frustrations of using them is you might have to adapt as you are trying to get into them. Okay, so let's switch over to RStudio for a minute. And we will take a look at how to write some code to access Blue Sky's API. So up at the top here, we're installing a package that a developer wrote to allow our users to access Blue Sky data. And that package is called ATRRR. I'm not sure exactly why they chose that name, but if you want to follow along with me here, you would need to first install the package. I already have it installed in my session, so I'm going to comment that out so that I don't accidentally reinstall it, which can occasionally create a headache. Next, I have to load the package. So I'm just using the library function here to load that package. I'm getting a little warning message that says this package was built under R version 4.3.3, but that's probably okay. It's just simply telling me that when the person who wrote this built it, they were using an older version of R. It's a useful warning to get because it may mean that something that changed about R itself. So when we downloaded R, we downloaded a version. And periodically when you use R or RStudio, you're prompted to update your R, which version of R you have. And that can create an issue. But for now, I'm not too worried about it. The next thing we need to do is authenticate. We're going to talk about authentication a lot more when we talk about OpenAI. But for now, the most important thing you need to know is the API needs to keep track of who is requesting the data. It may be for many different reasons that we'll get into in just a minute. And so for this R package, the way you authenticate is with this function called auth. And then you have to pass the name of the username of your Blue Sky account. So when you click auth here, let's see here. Focus on, fingers crossed. Nope. Okay. It's not happening on my other computer this morning. Sorry, folks. Pro parse, not a. Okay, so we've got a little bit of a bug here. I was just talking about how the version of R may be consequential, and the computer that I wrote this code on is a newer version of R. So my next best guess is that what has happened is that we are dealing with a version issue. It looks like especially a function that this package calls, which is called curl underscore parse underscore R. So now let's try to solve this problem together. And one way we can do that is to install the latest developer version of the account rather than the account that was created by um, that was added to the central R archive network, or CRAN. So I'm going to go to attr package R. I'm going to move over for those of you online. And I believe it's ATRRRR. Okay, interesting name. So here you can see we're actually looking at what the package, the R package looks like. We haven't a lot in this class gone through and installed packages directly from GitHub. We've been installing them mostly from the central R archive network using install.packages. But it turns out there's another way to get the most recent version of a package. And as long as we're here on GitHub, this is a teachable moment. Let's take a look at a little bit at how GitHub is set up. So you can see here, we've got a user. Here's my account here. You can see different people are starring this, this repo or repository, which is what we call the different parts of GitHub where software lives. So people are starring it here. You can fork it. That means that you take the code and expand upon it later. You can watch it, which means you get updates about it. But most GitHub pages look like this. They have some news about the author, and then they have the actual code here. So if we look in this R folder here, this is the code that the person used to write the auth function that that we were just using. And so you can see here, under the hood, eventually there's just R code. Now this is pretty sophisticated R code, so you might not have seen this if you're new to coding. But the cool thing about knowing this is that, like, let's say we had this problem and we actually had to solve this error we're getting, we could actually change the functions. Like, let's say, I forget, it was curl URL parse, right, that was throwing our problem. So we could find where that is in the code and then debug it systematically. That's one of the cool things. Even cooler would be to share any solutions we had with other people, right? And it just so turns out that I'm noticing here, if you look at the last commit message, a commit means to add something new to the repo. And so as people build software collaboratively, they commit changes, and then the owner of the repo sort of can approve them or disapprove of them. And that helps us keep track of how software grows and when it changed. So I'm noting here that auth.r was fixed. Something was fixed 2 months ago, and my working hypothesis is going to be is that I installed R later on this computer than I did on the one that I used to write this code before this class. So what that means is the latest development version has a fix that the version that's currently in our RStudio does not. And so when this is an issue, we can install what's called the development version of the package. So here, if I scroll down beneath the code, there's usually a README and other information that helps me understand how this works. The README looks like this. So it tells me what the package is, how it works. And then it tells me I can install it from CRAN like I did here, but I can also install it from GitHub. And what this means is that I'll get the latest version instead of the most recent CRAN or CRAN version. Now, the CRAN version is often the most stable. So one thing with installing the development version is that it might not be very well tested yet. All of this open source software depends on people using, testing, and sharing, and then testing each other's code. And so I'm hoping that if I install it from GitHub, it will fix our problem. So I'm going to grab this little chunk of code here. And what this does is give me the ability to install a package onto my computer from GitHub. Now, one thing you want to note is anyone on the internet can produce anything. And we're sort of depending on the goodwill and careful nature of so many software developers to catch bugs or vulnerabilities in code. But one of the challenges of using the GitHub development version is there are even few people that have done that. So I happen to know people who built this package and who've used this package. And so I have a moderate level of comfort. To be honest, I would love to have the time to read through every single line of code, but there's it's just something to be aware of as you start to get into the development versions of things. Okay, so now we're going to switch back to our studio and we're going to cut and paste that code. And first thing we need to do is install a package that allows us to install packages from GitHub. And that package here is called remotes. So I'm going to go ahead and run that line. I'm being forced to restart my R, which is a bit of a pain, but not too big a pain. And now you can see that package is installed. And now these two cursors are saying that from the remotes package, please use the install.github function. And by the way, I happen to know there are multiple packages that have a function called install._github. And that's why knowing about these two colons is useful, because this allows you to say, I want this function from this package. If we just wrote this, R might get confused, especially if I had another package loaded that had a function called install GitHub. So I actually don't have this one. I usually use a package called DevTools, but let's go ahead and try it. Okay, great. So in our console down here, you can see it downloaded the latest. It wants me to update some other packages. I'm going to go ahead and say yes. I haven't done that on this computer for a while. But, as with all these decisions, some of these can be consequential. I think it's likely that the reason I'm doing it right now is I think that curl function that we got stuck on, it might have needed to be updated too. So hopefully we can try that again. And we're going to need to load the package one more time, I think. So I'm going to move that down here. And I'm going to get rid of our cran version and fingers crossed. Aha, it worked. Live coding is fun. All right. So what this means is that we can give it a password in order to get in. So I need to add my password, which I'm going to cut and paste here. Just give me a minute. Shoot. Live coding, always fun. Minute here. Okay. Just for a minute, I'm gonna unplug while I share my most deepest secrets with the world here. Let's see here, 01. Okay. Okay, now I need Blue Sky. So I'm just grabbing my Blue Sky password, folks. Sorry. Okay. I've got it. And I have pasted it into my RStudio console here. Sorry, the projector's taking a minute to warm up. So when I hit OK, now we're in. And you can see down here, it said I had to create a new app. Remember, I mentioned that earlier. Sometimes we have to create an app in order to authenticate, which is, again, establishing our identity vis-a-vis the API. And why we do that will become more clear in just a minute. And then you'll see here, I got this successfully authenticated message here. Okay, so now let's finally use the API and do something fun. I was trying to think of who to whose tweets to grab, and we just read some of Nicholas Christakis's work. And so I thought it might be interesting to get, and by the way, he's really concerned about the measles outbreak right now. And so I thought it was just an interesting kind of data to get. And you can see here, there's a get skeets authored by function here. And so that allows us to, as we mouse over here, you can see what kind of arguments we could put into this function that the author of this package wrote. So first we need the name of the actor, which here refers to the Blue Sky account. So that's na.christakis.bluesky.social. We can specify a limit of the number of messages we get. By default, it's going to choose 25, though we could probably choose 200 or 1,000, I would guess. And then we can ask it to do other things, like whether we want it to parse the JSON data that it likely returns into, say, a data frame. So let's go ahead and run this and see what it does. It says it got 25 results, all done. And now, as I come back over here, you can see I have an object now in the data frame. And these are the actual messages that he put out. Second measles death in a different state. What you're seeing now is all the different types of metrics we can get. So if we wanted to do a study of, say, virality and figure out whether social networks are helping things spread, we might want to say, look at the number of likes of a given post, and this could go into a model that we learn how to build later in this class or in other online courses. So there's a lot of stuff in here. You're probably wondering, what is in reply root, right? Like, these are all terms that whoever built the Blue Sky API came up with to refer to different things or endpoints we get from the data. And so one way, like this one caught my eye, right? It has 13,000 likes. So what's going on there? Let's take a look. We come all the way back here. This URI, I wonder if we can just go ahead and cut and paste it into a web browser. No, we cannot. Sometimes APIs provide a URL that allow us to go directly to the it looks like one of these probably would. I'm not sure which one. So this is a sort of, again, a teachable example because I've never used the Blue Sky API before today. So to find out the answer to this question, we would need to go read the documentation to figure out what exactly each of these data tables refers to. But as you can see here, we've collected some pretty cool data already. And you could imagine doing a lot of cool research, looking at, say, social networks, looking at how information travels on the internet, looking at, in this case, health, although we could have chosen many other different types of users. We could have found a sample of users, like, let's say, elected officials or something like that, and tried to track them. We could try to look at the types of language they use and whether that is associated with some kind of outcome, like how frequently their posts are shared. And we might have a hypothesis to test about, like, whether negative messages go farther than positive messages and things like that. So anyways, this is I think a good example of how we might use a very open API to collect some data. Now we have about 20 minutes left, and now I want to get into a more complicated example. I'm going to take questions at the end of the class, and this is just to facilitate people who are watching this remotely or later. And now let's go back and take a look at a different kind of API. And that's going to be the OpenAI API. But before we do that, I want to tell you a little bit about authentication. So when we went in through Blue Sky, the only way we needed to authenticate was to put in our password for Blue Sky, which is sort of a nice function. But most APIs require something called credentials. And credentials, you can sort of think of them as your password and username to use the API. So here, for example, the client would be like our computer, although it could be a virtual computer, it could be another app, it could be all sorts of stuff, which is why has this abstract name client. And each client needs an API key. And so you can think of that as sort of my identity. So we're about to write some prompts for ChatGPT, and we want to create a bunch of responses. But OpenAI needs to know that it's me and not someone else in order to know which type of models I'm able to use, how many times I'm able to make requests, and also in the case of a paid API, what types of payments I've made that entitle me to use what types of features. Now, fortunately, there are lots of different LMs. Some of them have a lot of free tiers. So you'll hear about tiers. Those are usually pricing tiers. And so the more you pay, the better models you can use sometimes, and then the more you can use them. So we will also be talking to the API server. So basically our client, in this case, for many of you, it's going to be like your laptop. We're gonna send an API key to an API server, and then we can get to a database, which in this case is not really a database because it's the large language model that we're talking to do inference with the large language model. But if we weren't allowed access, we would get some type of message that says we're unauthorized. Now, we don't always see that message depending on how we're interfacing with the API. And so one of the most common reasons people fail when they're trying to use APIs is they don't get this authentication stage right. So now let's take a minute to look at OpenAI's API. And broadly, what we're trying to do here is to send the API a prompt, like listen to your, and then get some kind of response, like heart, right? And so let's switch back over to our web browser for a minute here in order to see what it looks like to sign up as a developer who wants to use OpenAI. Okay, so I'm going to Google OpenAI API. And here you can see the main site. You'll notice also there is this thing I mentioned earlier called a playground, which allows us to test certain kinds of code. And you'll see quite quickly, it's very well documented, right? There's a lot of different stuff. You can use the API to do audio generation, image generation, text to speech, speech to text, all sorts of other stuff. You can use sophisticated prompting techniques like function calling, which we don't have time to get into today. You can even fine tune your own LLM here, which we also don't have time to get into today, but hopefully we'll get into when we talk about LLMs in a future class in more detail. And then here you can also see there's some best practices. There's a forum where you can ask for help and a few other things, understanding data codes. So we're going to use, we're just going to use it for text generation here. And so here you can see there's a tutorial here that's going to take us through how you would write code. This is code in JavaScript. We can change the language here. So if we're using Python, we could use that. We're using curl, which is another language we often use to interface with APIs. We could use that. Unfortunately, R isn't a choice here, but there are easy ways to call Python from within R, assuming you have Python installed in your computer, or you can quickly rewrite this code using R, and that's the approach we're going to take today. And you'll notice like there's similar things in Python code, right? Like we're loading a package. So this is sort of like our library package, and then we're saying which function we want to use. And then this client is the way we're going to authenticate. We'll go over that in a second. And then we're just specifying the model we want to use. And then here's the prompt. Write a haiku about recursion in programming. Real cute. You can see there's a lot of different parameters we can change here, like the model. We can change the system prompt, which is what tells the API what it should be. Like instead of saying you are a helpful assistant, we could give it a different persona or a different set of choices. So as you can see, we could read a lot. We don't have time to get into it. Which model should we use? How, what's the best practice for prompting? How should I handle the output most efficiently? If you really want to master the API, you got to learn all this stuff. But usefully for us, there is a OpenAI package in R. And if you want to work in Python, you'll note that there's also an OpenAI package in Python. And so this one we can install from CRAN. So if you want to follow along here, we can just quickly look at the package and what it does. It says it's an R wrapper for OpenAI API. A wrapper is a tool that helps you create the URLs to make the requests we looked at when we looked at that first Google example, and also to scrape and parse the data. This package has been around for almost 2 years, so it's fairly mature. Lots of people use it. You can see all the different kinds of functions in here. I can see here there's one for create chat completion. So even though on the web, when we're talking to, say, ChatGPT, it looks like it's just a dialogue. Technically, what that website is doing is making an API call to the chat completion endpoint and returning the response from that endpoint. And then it's passing previous messages into what's called the context window, which we'll learn about in a previous class, and then doing the same thing. But you can see you can also create images with this package and things of that nature. So if we want to use this, though, there's another step we have to do, which is to get our API key. So I mentioned before, we need sort of a secret password to access all these things. And so to get that password, you have to come up to the right here. And yours is going to look different than mine because I'm currently logged in with my account. But I'm gonna try to show you what it looks like for the first time here. You should see a green sign up button up here. And if you came through here, there's various ways to sign up. Once you sign in, you would get a, I happen to use Google, but you could use others. Then you'll start to see that you have a variety of different ways to access content, but then you also have your own actual API keys. And I don't want to show them on the internet, so I'm not going to click on mine, but if I clicked here, I would get a long string of numbers. So an API key often looks just like a bunch of numbers and letters, like just total random string of stuff. And then I can take that and use that to authenticate with the OpenAI package. So here, just coming back over to RStudio for those of you who are online. And what you can see is you need to install this package. So I've already got it installed on this machine, I think, and I'm going to try to figure that out by trying to load it. And it's being slow for some reason. Not sure why. Huh. Okay, it looks like it worked. Sorry. I think this Zoom crayon was just obscuring it. Okay, so I loaded the package, and now to authenticate, to announce my identity vis-a-vis OpenAI, and therefore determine what I can and can't do with the API, I need to cut and paste my API key here. So you need to keep these quotes around, these quotation marks, single quotation marks around it, because it's a string variable. And make sure if you're cutting and pasting that you don't accidentally omit the first or last character. If you triple click on text, it will automatically select anything within the whole text box. That can be a good way to ensure that you actually get the whole key in there. Another common mistake is people will leave a space at the beginning or the end of the API key, and then you'll get an error message saying that your API isn't working. So I've already run this code with my API key before we started. So you can't see my API key, but yours would be right here. And then you just run all of the code with this sys set environment function here that we're seeing that the author of the OpenAI package created. So here's where the fun begins. Now you can see the OpenAI R package has a function called create_chat completion. And here we give it a model. I've defaulted to using a smaller model for two reasons. One is this is part of the free tier of access to OpenAI. So hopefully, unless something has changed recently, you should be able to use this a few times for free. But second, it's a smaller model that has less of an environmental impact. So remember, every time we're using an LLM, there's a cost in terms of our carbon footprint, and these smaller models tend to, and actually there are even smaller models now, like the mini models, which would be even better to use. And if we wanted to know how to change the model, we'd need to know the name that the API developers gave to the model. So I can't just type in GPT-4 here. I have to know exactly, I would have to look in the documentation to figure out exactly how GPT-4 was described and what's the exact, so if it's a capital letter, if I'm off by one character, the API won't know which model I want. Now, this is a little tricky. The prompt here is what is betweenness centrality. So we know about betweenness centrality from our lectures, previous lectures on social networks. It's a network metric that helps us identify influential people within a network. And you'll see here that this is a little bit of a funky function. There's this part messages, which sort of explains whether we want to change the user prompt, and user is the person making the prompt, or the system prompt. So for example, if we want to tell GPT 3.5 not to be a helpful assistant, but to be a famous author that is inspired by Picasso or something like that, right? We could do that. And we would add another line here that says system, and we could give it a different system prompt. But to keep things simple, we're simply saying the user is passing this prompt, what is betweenness centrality, to GPT 3.5 Turbo. And so when I run this here, you'll see down here, I didn't get any output yet. And again, this annoying Zoom thing is sort of obscuring the cursor there, but it just shows that it ran. And now you'll see I created this object with that function called chat output. And so chat output has a lot of stuff here. If we look at, we can browse the data object here, and we can see when we use the API, it gives us all sorts of stuff back. The thing that we want is called choices and message content. So these $signs, or what's sometimes called the atomic operator, allow us to index JSON output. So this is a list of JSON, and the way that we can extract different parts of the JSON is with that $sign. We don't want to get too deep into parsing JSON today because someone has done most of it for us, but just in case you find it confusing that there's two $signs, maybe you've seen using $1 sign to index a data frame before, you can use multiple $signs to index a JSON document. So now I'm going to try, actually going to delete this and just see if we can get it to give us the answer. And lo and behold, betweenness centrality is a measure in network analysis that quantifies the extent to which a particular node lies on the shortest paths between all other nodes in a network. Now, you might be asking yourself, why do I need to do this, right? I could go to ChatGPT and ask the same question, right? But now imagine that you had 1,000 questions or 20,000 questions, or you wanted to create multiple agents to simulate a social world in order to do research, for example, right? There's enormous power in being able to programmatically interface with an LLM. And before I open it up for questions, I just want to show you one other thing that you need to know before you go wild with an API like OpenAI, and that is the concept of rate limiting. So if we don't specify in our code how many requests we want to make within a certain time frame, then we will be rate limited. So rate limiting is when rate limiting is when we make a certain number of requests. So this image is from Twitter. And so, within 10 minutes, I can only collect so many thousands of tweets. This is thousands on the y-axis here. Before first, the API will start throttling me. That means returning the responses slower. And then eventually, when I am actually rate limited, when I have exceeded the number of requests that I can make within a predefined set of time, then it will stop giving me the data altogether, and very commonly prevent me from making any further requests for some specified period of time, maybe 10 minutes. Now, I can't tell you, and many APIs won't tell you exactly what the rate limits for an API are. So for example, you might want to know, well, is it exactly 1001 prompts I can send to OpenAI within 15 minutes? You could look at the developer documentation, and some APIs will tell you exactly what it is. but many do not make this information public because they don't want people to go way up to the edge of what's possible and push the system as much as they can. And so there can be a little bit of a cat and mouse game, because you can imagine if an adversarial actor created hundreds of fake OpenAI accounts and then started wreaking havoc on, say, Blue Sky with bots, which we just saw you can do, right? You can make bots with the API. That would be really bad. So they want to have some ability to constrain, and also thinking of environmental impact, and also thinking of, in the case of API, like you have to pay for those credits eventually. So they have to have a way of stopping you from making more calls than you're allowed to make with what you have. So what this means is if you are using an API, it's wise to build pauses. If you, let's say you're writing a loop, and the lab for this week actually asks you to write a loop to collect data. You're going to want to build in a pause in your code. And one way to, so you might say every time through the loop, at the end of the loop, pause for 1 second. And so in R, you could do that with the sys.sleep function, and then you specify the number of seconds that you'd like R to sleep for. And you just put that at the end of your loop. Some APIs allow you to make API calls to figure out what your rate limits are. And if you have that functionality, then you can build that into your code too, to develop an even more efficient way for collecting data. But broadly, I just want you to leave the lecture today knowing about credentials, right? You often need an API key. Sometimes, by the way, those are called different things like API secrets or API tokens. All that refers, sometimes a shibboleth, all of that refers to the password you need. Sometimes APIs have multiple passwords, so you might need a secret and a token, an API secret and a token, and you might need a function that passes both of those things, which are actually, by the way, appended to the URL call if you were writing it from scratch. Like you're actually writing a long URL, and then at the end, very often it would say something like access token equals blah, blah, blah. So that's what you're doing conceptually. We're just not seeing it happen because we're conveniently using these R packages that do that for us. Okay, so before I take questions, I just want to introduce the main goal of the lab. So the lab is to authenticate with an LLM of your choice. You can use OpenAI, which we showed you how to do today. But if you want to challenge yourself, you could try to use another LLM like Gemini, or you could try to use Anthropic's models. You could even try to use Llama, which is like an open source model that you can run locally on your computer. We don't have time to get into how to do that today, but there are apps like Llama that allow you to download all of this, like say a small version of Llama, and then use it interactively on your computer for free without any interface with Meta. And you can write API calls, or we sort of call them pseudo API calls, to that locally run large language model to do the same thing. I think that's, I wouldn't advise that if you're not really interested in getting your hands dirty, because there are some complexities into installing it. Although the Llama app makes it a lot easier than it used to be. Okay, so you authenticate with an LM of your choice. If you're using the local model, you don't need to authenticate, by the way, for most of them. And the second task is to generate 25 short narratives about a doctor. So here what I mean is give it a prompt that says,